All right, we have now laid all the groundwork in the previous video, so we are ready to start factoring polynomials. And you're going to see a question like this in my math lab. It says, for the polynomial f of x, part A is going to want you to list all of the potential rational zeros. So that is our p over q. And then let's look what our p and our q are. P is this 20 here, or technically negative 20, but the sign doesn't really matter. And if I don't see anything in front right here, then that means my q is 1. So when my q is 1 here, it really doesn't matter what p is. P over 1, 20 over 1, anything over 1 is just what that top number is. So here, all I really need to do is list my multiples of p, or my factors of p. Okay, so to get to 20, that would be plus or minus 1, plus or minus 2, 3 doesn't go in, but plus or minus 4, plus or minus 5, 6, 7, 8, and 9 don't go in, but plus or minus 10. And then that is half of 20, so nothing else is going to go in there. So those are my potential rational zeros. So if you kind of notice, we have 2, 4, 6, 8, 10, 12. This is just a little side note here. Let me go into different color. We have 12 possible rational zeros. Okay, but at most, how do I want to write this? But at most, there's how many zeros? Well, here, because this one's an x cubed, there's at most 3 zeros. Okay, but I have 20 possible rational zeros. Okay, so now it says in part B, use the graph to eliminate some of the potential zeros. So, if you were using a graphing calculator, I have a playlist for graphing calculators. But I'm assuming since you're here in this playlist that you are going to be using Desmos. So if I go to Desmos, I'm going to type in my function. Okay, so here is my function. And let's kind of split this screen real quick. When I want to graph this to eliminate some, I first want to figure out what are my biggest and smallest possible rational zeros that I can have. Well, whatever this biggest number is also the smallest number. So what I really want to do here for part B is I need an x min of negative 20, and I need an x max of positive 20. So I'm going to go in here to my little tool gear thing, graph settings, and this is going from negative 10 to positive 10. I want this from negative 20 to positive 20. Now I can't see where this min is right here. I can go down. I can see that min's at about negative 24. I don't really care about those. What I'm caring about is where this is crossing that x-axis. And so in your homework, you can see negative 20 and 20. It's clearly not there. It's clearly not at negative 10 and 10. And so when it wants me to eliminate some, I am eliminating positive and negative 10 and positive and negative 20. Because it's nowhere close to those. Now we can kind of zoom in. And now what is my next biggest and smallest? That's that plus or minus 5 right there. So I'll go -5 to 5. And here are my zeros. So I do know I have at most 3, and I can see all 3 here. We have 1, 2, 3. Now here we have all rational zeros, which makes the problem super easy. We have -5, -4, and 1, which are numbers here that were our possibilities. We have -5, -4, and +1. So from Desmos, we can see that we get -5, -4, and 1. Now, they're not always going to be all rational zeros. More times than not, you're only going to have 1, at most 2. So let's kind of go through the process. What would happen if I only knew 1 rational zero? The other 2 were irrational or even imaginary, which we're going to get to. Okay, so let's pretend that I could only tell it was this first number here, this -5. So what would we have to do? Well, just like in example 3, we need to divide that out, and we'll divide that out using synthetic. So look at your function. Do you need any zeros? We got x cubed, x squared, x constant, so no. So we have 1, 8, 11, and -20. Bring down your first one, multiply, add, multiply, add, multiply, add, and we get a remainder here of 0. So that also tells me, not just by the graph, but by synthetic, since I have a remainder of 0, it does go in evenly. So this is my x squared, x, and constant. Whatever you had here, it goes down. So if this was x cubed, now it's x squared, x constant, or you can work your way up, right? This is remainder, constant, x, x squared. Okay, so what I have left now from here is x squared plus 3x minus 4. From here, the whole goal of these is to be able to find enough zeros to factor out or to use synthetic division and get it down to a quadratic. And once we get it down to a quadratic, now I have 3 methods: factor, square root property, or quadratic formula. Let's always check factoring first when I have 3 terms, right? So my a times c is 1 times -4. My b term is 3. So what adds up to 3, but multiplies to a -4, and that will be 4 and -1. Now, luckily with this one, unlike with example 3, what I'm left with is an easy trinomial. So that means this is what this factors to be. So this will be x plus 4, which when you solve that, that's going to give you x equals -4, and x equals, or x minus 1, which when you set that equal to 0, you get +1. Okay, so that's going to be the process if I can't find all of those like I can in this one. Now, whether we get it from Desmos, we go through this process. Now it wants it to be in factored form. Factored form means your parentheses. So I'm going to change this one. Well, let's go ahead and do f of x equals. Then we will have x plus 5, because we're changing that sign. Change that sign to x plus 4, which is what we got here, and change the sign to x minus 1, which is also what we got here. So this is my final answer. Okay, let's try again on example 6, where this time I will have to go through this process because I'm not going to have all rational zeros here. So example 6, Use the rational zeros theorem along with the graph to find possible real zeros of the polynomial function. Find the remaining irrational zeros and factor the polynomial over the real numbers. So it does tell me to use the rational zeros theorem, which is this P over Q. I don't really think it's necessary, so I'm actually just going to go straight into my graph here. So I'm going to type this into my graph and I'm going to see if I have a 0. Okay. Okay, so here's the graph that I have on this window. I am just going to, well, I was going to say zoom out, but that's not very helpful. This is a cubic, but it's got barely any kind of movement right here. Let's go. And I'm just playing around with this window to make this graph look a little bit better here. So I'm going to go -10 to 10 on my X. And then on my Y, let's go -100 to 100. Oh, that's why it looks weird. I got 2 cubes right there. That looks so much better. Okay. Why is this graph looking wonky? Okay, it helps if you type it in right. So I can see now, here's my graph and I'm happy with that. So I've typed that in now correctly. I'm gonna go ahead and just slide this over so this graph gets bigger. And I'm gonna go split screen real quick. Okay, so it wants to know a possible 0 from the graph is blank, thus should be factored. Thus, a factor should be what? So I can see I have an x cubed here, which does mean I should have at most 3 zeros. And I can see those 3 zeros. That is crossing this intercept, or this x-axis, 1, 2, 3 spots. Now, only one of them gives me a nice clean number, and that's this 2 right here. So we know a possible 0 from the graph is x equals 2. Thus, the factor should be, switch that sign, x minus 2. Now, part B wants me to use long division to find the reduced polynomial and then find the remaining zeros. Do I need to use long division if I'm dividing in an x minus 2? No. Now, if you like long division, go for it. But I'm going to be using synthetic. So we'll put the 2 on the outside. Do I need to skip any, or do I need any zeros as placeholders? And no, it goes x cubed, x squared, x constant. So this says 1, -2, -23, and 46. Bring that one down, then multiply, add, multiply, add, multiply. So here's my remainder. So that tells me it is a factor. Then it goes up from constant x squared. So this now becomes x squared minus 23. Now, that's the goal. Factor out at least, hopefully, one of them. Get this down to a quadratic. Now we have 3 ways of solving. We can factor, square root property, or quadratic formula. Excuse me. We could use the quadratic formula. I can't use factoring because that is not a perfect square, but this one, without having that b term right there, this is a really good one for square root property. So if I just turn that into an equation by adding in an equal 0, I need to solve this for x. So the first thing I'm gonna do is add over that 23. The opposite of x squared. So take the square root. Now again, that's not a perfect square. If I could, I would need to break that down, but the only way to break down 23 is 1 times 23, prime number. So this is x equals the square root of 23. And then I am forgetting something in my answer. What is it? When I have an x squared, I should have 2 answers. Just like when I have an x cubed, I should have 3 answers. So where do I get my second answer from? We need to remember that square root property. When you take the square root, that is plus or minus the square root of 23. Now, we can use that graph to keep checking our answer. We already found on that graph that x equals 2. Can I find the square root of 23 on that graph to check to see if this is correct? Okay, well, if I get a calculator here. And I put in the square root of 23, I do get that 4.79583. So that is on my graph, but it's just not going to give that to me in radical form, right? It's going to give it to me as a decimal. And then you have negative square root 23, which gives you that as well. Let me find the other calculator real quick. If you have a TI-30, when you put these in, it stays in exact form. So if you put in square root 23, it's going to give you square root 23. You need to hit your toggle button, and that will give you your decimal right there. So you can check that. Okay, so then lastly, use the real zeros to factor your f of x. So we already found one factor in part A up at the very beginning. We have this x minus 2. And then here are my other 2 factors. So we'll have x plus the square root of 23 and x minus the square root of 23. So this is my cubic in factored form.